Alright, this is number 27 on page 336. I'm going to take a quadratic function and I'm going to convert it into vertex form so I can name the vertex, and that's going to give me the minimum or maximum value. And I'm going to name the domain and the range, and then I'm going to find the zeros of this function, which are the x-intercepts. So the first thing I'm going to do is replace the f of x with a y, and I'm going to rewrite this in the right form. So this is going to be a negative x squared, a minus 2x, and a plus 8. So I'm ready to start completing the square process on these two terms. So I'm going to factor a, which is negative 1, out to the front. And then I'm going to have x squared, and then a plus 2x plus blank to complete the square. My 8 is still being added, and then I have to say minus blank, because whatever I add here, I have to subtract when I'm on the same side of the equation. So the perfect square trinomial that this is going to be, I'll still have my negative 1 out in front. This is going to be x plus half of 2, so x plus 1 quantity squared. So when I square that 1, that half of 2, I get a 1. And what I've done is I've added a 1 times negative 1 to the right side of this equation. So that's really, I've added a negative 1, so now I have to subtract out a negative 1. So I've got x plus 1 quantity squared is equivalent to this. I still have my a of negative 1 out in front, and I have a plus 8 plus 1, so a plus 9. So that's going to get me my vertex being at negative 1, positive 9. So vertex is at negative 1, positive 9. Now as far as the direction of opening, this tells me that this parabola opens down. So if it's going to open down, it's going to have a maximum value at positive 9. So I'm going to put that as a note here. The maximum value is going to be positive 9. So I'm going to plot my vertex at negative 1, positive 9. So vertex at negative 1, 9. And I'm going to sketch in my axis of symmetry. Okay. Now, the domain of this function, we know it's going to open down, but the domain of the function is any value of x, so all real numbers, the set of all real numbers. And because the graph is never going to get any higher than negative 1, 9, the range is going to be all values. Y values are all going to be less than 9, so y is less than or equal to 9. So now I'm going to find the zeros of the function, which is where it's going to cross the x-axis. We know that this is at negative 1, so it's going to be some amount to the left of negative 1 and then that same amount to the right of negative 1 where this graph comes down. So to find the zeros, I could set this equal to 0, and I could try factoring this, which it actually does factor, or I could use quadratic formula or completing the square. I've got it in vertex form. I'm going to go ahead and work with it in that form to find the zeros. So I think I'm going to do that right down here. So y, I'm going to set y equal to 0 is equal to negative 1 times x plus 1 squared plus 9. And now I'm going to subtract 9 from both sides. And I'm going to divide both sides by negative 1. So I have 9 is equal to x plus 1 squared. I'm using the square root method, which is nice and easy. So now I'm going to take the positive and negative square root of both sides. So on the left I have a 3. So this is 3 is equal to x plus 1. So x is equal to, I'm sorry, this is a positive or negative 3, is equal to x plus 1. So subtracting 1 from both sides, x is equal to negative 1 plus or minus 3. Well, negative 1 plus or minus 3, those are all rational numbers. Negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. So this should come down at positive 2 and negative 1, 2, 3, 4. Notice that this is to the right by 3, of the axis of symmetry, and this is 3 to the left of that axis of symmetry. So those are our two zeros, 2 and -4. And it's coming right down on those points. And it's going to cross the y-axis here at 0, 8. And the way we know that is if I set this equal to 0, I'm sorry, if I set x equal to 0, then y will be equal to 8. So that's kind of a side note, but that point is there. So anyway, those are the two zeros of that function. And again, since these are rational numbers, it means that the original equation could have been set equal to 0 and factored if you want to do it that way as well. So that is it.